Did you say you were playing Xbox? What were you playing? I have no idea what that is. You saying Minecraft is not realistic? Cool. Alrighty. Let's get going. Okay, so a couple of things. I can hear you. I'm gonna mute you though. That's because, yeah, that probably is why. All right, so I wanted to talk about a couple of things first. One, homework, right? Not due until Wednesday. There's a homework on. We just didn't finish enough. We kind of split 11/7, and so I didn't feel like we had enough to assign for today, and so there's a little bit longer, although not exceptionally long, homework for Wednesday, and then today. So we're starting chapter 7, right? So we're kind of going, I guess, backwards. Hopefully this stuff felt a little bit more chill after series. I mean, kind of getting back into integrals and areas. A lot of this is drawing the right picture. So 7.1 actually has two parts to it. So we really only talked about the first one in the class prep video, and we'll see how far we get today. I do have the worksheet up on Canvas if you haven't pulled that up. I mean, I'll write down what the problems are that we're kind of going through, but if you want to follow along, like I always put those up basically either the night before or the morning before. So the other thing in 7.1 is going to be arc length. We know how to do length of straight lines, and so the idea is we would like to be able to do the length of curved lines, and it may not be that shocking that this is another kind of limiting process and kind of has to do with the derivative. And in fact, this one actually also involves the integral as well. So, you know, approximating things by things we already know is kind of the theme of calculus, and so that's another one where this makes sense. So I'm not sure if we'll get there today or not. We will just kind of have to see where we end up. And I want to make one other comment. If you guys are working together online and stuff, I know that, mostly like Reese has been going live. If you guys are like, I recommend either more than one person going live, or if you only have one and you're kind of talking through that, then like really be sure that you are collaborating. Okay. Um, Gentleman's rule stuff. I just want to say that, and yeah, just make sure it's truly collaborative. All right. Okay. So area between curves. I want to talk about the second one on the class prep, mostly because I saw a few issues with that. It went pretty well in general. But this should take you back a little bit. I mean, obviously, the process is very different, and in general, these are much less involved. But I want you guys to think about these almost like a related rates or optimization problem, where like the first thing you should really do is try to draw these things. And if you don't know exactly how to draw them, then maybe find the intersection points first using algebra. But basically, like before you actually set up the integral, you should be drawing something. So make sure you are draw the picture before you set up the integral. Right, so with this one, we had, other way around, y squared minus 4, and x was 2 minus y. And so if you just do, right, like you could probably just draw these straight away, but if you want to find the intersection points, because these aren't too bad, but I think find the intersection points is fine first. So you would set those equal to one another, right? and then you get y squared plus y minus 6 is 0, and this guy is easily factorable. This is y plus 3 times y minus 2, and so y is either negative 3, I don't know why I put parentheses there, or 2. And in terms of drawing it, right, so the first one, maybe I'll do this one in red, this one in blue. So for the red one, you should look at, okay, so when y is 0, right, we're going back here at like negative 4. That's kind of our starting point, and then it's going to open up to the right, right, because we have y squared with a positive thing, so we're getting increasing x values. And we know that it's going to hit y equals 0, or x equals 0 at y equals plus or minus 2. And then it keeps going, and so when y equals 2, you can figure out what exactly you want. So, right, well, I guess that's all we need, right, because this is our right endpoint. Okay, and then we have 2 minus y, and so for this guy, right, we start at x equals 2 here, and then we have slope negative 1, right? This is poorly drawn, but that's fine. Okay, and so when y equals negative 3, I get 5 and 5. So at x equals 5, or sorry, x equals, yeah, 5. Right, so if y equals negative 3, you can just plug it into one of them, figure out where the intersection point should happen. So x is 5, and then our other one we see pretty clearly is 2, 0. So our two intersection points are 2, 0 and 5, negative 3. I'm sorry, 0, 2. X and y. Okay, so we got this guy, and then 5, negative 3 down here, so I guess I'll keep this going. There we go. And so these are our two intersection points, right? And so once you've actually drawn this, you see that this area is given, remember, so for the x, we do top minus bottom. And so for the y, we do right minus left. And so I saw probably about like half and half on this, and I think the main reason is just like not drawing the picture. Once you draw it, it's pretty clear like which one has to go first, right? So here we're going from negative 3 from your bottom up to 2, and then we have the one on the right, which is 2 minus y, minus the one on the left, which is y squared minus 4. And then that's dy. Okay, so again, just key is draw the picture, basically. Any questions on that one? All right. In that case, we will move along. Okay, so the first one for today is basically, yeah, two parts. I want you to, first of all, try to find an intersection point, and then try to actually graph this so that we can like set it up. So with this one, we'll have f of x. So this is not a y1, but an x1. Okay, so take a minute or so, like literally it shouldn't take that long, it's a quadratic, to solve this and figure out what are the intersection points. And then just throw the x coordinates somewhere. Discord, Twitch. Whichever. And if you're done with that, then go ahead and see if you can start graphing it, but I can talk about strategies for that as well. Because obviously you may not always have a calculator. Yep. Yeah, so x equals 0 and x equals 3. Right, so, gosh dang it. All right. Okay, should be back. Right, so we would just set them equal. I'm just going to go ahead and do this out, right? So it's minus x squared. That would be minus 2x, so plus 2x because of the minus sign distributed, and then plus 1, so minus 1. Right, and so then you add that over, minus 3x, and then the 4 and 4 cancels, right? And so 0 equals x times x minus 3. Okay. Does anyone know, like, if you didn't have Desmos or a graphing calculator, like, do you have a nice way to so 4 minus x, I fully believe in your ability to graph, but what about f of x? Does anyone have a nice idea for how to graph that? You guys can use a mic as well if you want. Right shift by 1, down facing, up 5. Yeah, exactly. So use that fact that, you know what x squared looks like, right? And then x minus 1 squared is going to be shift right. All right, so x minus 1 squared shifts x squared right by 1. And then you have 5 minus this is start at 5 and then do x minus squared facing down. Right, so basically we know we're at the point 1, 5, and then we want to face down. So what are our points here? Points of intersection. So at 0, our y value is 4. At 3, our y value is 1. And so I'm just going to go ahead and put those to start because that's helpful. And so this guy, I guess all I really care about is that part. And it looks something like this. And then 4 minus x, well, this is linear, and I know the two intersection points, so I just get this, right? So this is my f, this is my g, and then I care about this area in between. And so the basic idea, right, is, again, like you do top minus the bottom because the top would give you like the whole area, if you added this stuff. And then if you subtract away the area under G, you've just subtracted away all of that gold stuff, right? And so when you're setting it up, what integral do we want then? We're actually going to go ahead and compute this one straight up. Euler. It's the other way around. Yeah, so we want top minus bottom. And from, right, we want x equals 0 to x equals 3, because those are our bounds in this case, right? If our variable is x, we want our bounds to be in terms of x. And so we have 5 minus x minus 1 squared minus 4 minus x. Okay. And then we just have to figure out what exactly this is. So I'm just going to rewrite it simplified. Right, so when we did this up here, you can do this, and I'm just going to go ahead and subtract that 1, right? So it's 4 minus x squared plus 2x minus 4 plus x. And then my last simplification, right, I can cancel these out. and add those together. So negative x squared plus 3x dx, and then we're good, right? So now we can actually integrate. It's just a couple of reverse power rules. If I plug in 0, it's not going to do anything, right? And so it's really just the 3 that matters. So it's negative 27 over 3 plus 27 over 2, which is 27 halves minus 9, which is minus 18 halves. So 4.5 or 9 halves. Okay. Any questions on that one? Yeah, so that's usually going to be when you graph it, you will see what is on top. It is much easier than series. And of course, they may cross, right? You can have more than the 2 intersection points. We saw a couple examples, but like they could switch. And you can have like one be on top on the left part and one be on top on the right part, for instance. Okay. I want to practice another graphing one. So this one I'm not even going to necessarily ask that you, well, we can set it up as well. But let's have f of x be this, g of x be 2. So obviously, again, I think you can probably graph 2 pretty well. How do you graph f of x? It's not that easy. Negative, right, 2, up 8. Yep, there you go, Max. Exactly. Yeah, so use what we know from way back and think about how it changes from something right? So like start with just the absolute value, shift right by 2, face down, and then up 8. All right, so we've got our absolute value, you got your V, we shift it right by 2, and notice I'm scaling things by 2 because I don't want to draw that many lines. And then we want to face it down, then go up 8. So it starts up here at 2, 8, and then it's facing downward. And I've basically made this so it's slope 1, right? Because everything, or it's 1 or negative 1. And down here, when this is negative 6, we would get negative 6 minus 2 is negative 8. So absolute value is 8, so that's 0. And then over here, it's going to intersect at 8. Oh, wait, at 10, right? Ah. Are these evenly spaced? It's fine. Not really. Oh, no. Made a huge mistake. Everything's fine. That's 8, and then this is 10. 10 minus 2 is 8. Cool. All right, and then the other one, I don't know why I didn't just draw that in red the whole time. There we go. It's my F. And then my G is easy. It's just Y equals 2. Okay, and this one, again, it would just be integral here. Where are intersection points? So this is a little bit harder to solve for. So there, if you draw an accurate graph, it's not too bad. Or you can do this and see when is 6 equal to the absolute value of x minus 2. And so it's either got to be positive 6 or negative 6 in here, right? So you get either x equals 8 or x equals -4. And so, I mean, this is like a little inaccurate, I guess, in terms of my drawing on the left part. But yeah, this would be the integral from -4 to 8 of f minus g. Okay, yeah, sure. What's a good example? Okay. Okay, so yeah, you guys can either talk in here, maybe break out into the different voice channels, but try to figure this one out together. So here you have an area of a region bounded by 3 functions instead of 2, and so this one cannot be done with just a single integral. Maybe the guys in the live stream chat, maybe Reese come back here and then you guys unmute yourselves and actually talk, and then it looks like the other one's got people working together and working together. That'd be about half and half, so that would work. Okay. Yeah, I didn't realize it always makes a sound. That's weird. It doesn't for me, but all right. So the idea, right, is we have several intersections. You look at intersecting two at a time. If you don't have like a nice way to graph things. So when is x equal to 8x? Well, that's easy. X equals 0. That's not a problem. So that's the point 0, 0. Then you would have like 8x equals 8 over x squared. Well, here, Jesus. All right. So I muted him. So here, x cubed is 1, so that's going to be 1. And then our point is going to be 8, or our y value, right? And so we get 1, 8, and then the last one is when do we have 8 over x squared equal to x? And you do the same thing, and we get x equals 2, and so this happens at 2, 2. What is it? I muted him. You can mute him. You can right click or just say out loud to shut the heck up. But yeah, I have him muted. I can server mute. There you go. Should be safe now. Okay. I feel terrible. I just server muted a student. All right, we're good. All right, so again, think about what this looks like. You know what 1 over x squared looks like, right? I mean, it's got the stuff down here. Oh, sorry, 1 over x squared, not 1 over x. So, sorry, it's always above. So it looks something like this, right? And so 8 over x squared is just going to make this steeper, right? So 8 over x squared looks the same, or at least similar. All right, so I will unserver mute you. Okay, so here we know it's going to intersect, right? So obviously we've got our intersection there, but then we have our guy up here at 1, 8, and then let's do 8 over x squared. Why do I always want to cross it there? X, and then 8x. Okay, and then this guy comes down at 2, 2. So it looks something like this, right? And then it keeps going, it goes up for a while, and it has a vertical asymptote. X goes through, this is not to scale, but it goes to 2, 2 here. And then 8x is much, much steeper, and it's going to go up here. And so the area we're talking about is exactly this area in here. Okay, so once you have the picture, can you set up the integral then, or integrals perhaps, that's going to give this to you? Feel free to use your mic or type that out. But yeah, how would you want to set this up? Because we don't just have like one thing on top. So that's part of it, Reese. So you have 8x squared over x squared on top, but like from where to where? No, so you can't do it in one. So this is 1. Yeah, you need to split it up. So this is 1 from where to where? Yeah, first integral. Sorry. Yeah, first integral from 8x to 2 bounds. So you don't want to bound you can do it with actual x bounds. You don't need to do 8x, but it's close. Yeah, so it's 0 to 1, right? So like you want to see what's on top, what's on bottom. So your first one, what's on top, it's 8x, right? This is 8x. And what's on bottom? Well, x is always on bottom. And then over here, 8 over x squared. So it seems like we have two cases. We have the 8x minus x, and then we have the 8 over x squared minus x, depending on basically this point here. We change it 1. And so, yeah, it's this from 0 to 1, and then this from 1 to 2. Does that make sense? You don't need to. We don't need to compare those, right? So like what we've done is we have, whoa. So we have something that looks like this. So we just kind of split it down the middle. And so basically you're looking at like this area and then this area and calculating them separately, right? So this guy, this is a top 1, this is top 2, and you have the same bottom. I'll put bottom 1 and bottom 2. But yeah, basically you're just doing this area and then this area. You don't need to compare the tops ever. Okay. See typing. Okay, cool. All right. So we're just going to do a few where we set it up but don't actually solve. Okay. So set up but do not solve. And obviously, like I encourage you to find the intersection points and draw a picture. So this one, and let's take like 4 or 5 minutes to try to do these two. All right, so feel free to again work together. And then we can do 2 final ones here together, maybe to end class after these two. We'll do arc length next time. Yeah, good question. Sorry, yeah, I should specify on 0 to 2 pi. Yes. Good, Paul. A good point. Otherwise, you will get all of the things ever. Okay, so it sounds like we were on the right track. So let's go ahead and go through these. So what does it actually look like? So from what I was hearing, these intersect at plus or minus 3. Right, so how do we get that? Okay, we get 2x squared equals add 6, 18. So x squared is 9, and thus x is plus or minus 3. And so these are my intersection points. And what's my y value there? So you can plug it into either of them, and you'll see that y is 3. And so, oh, sorry, yep. You can also use headphones, but yes. All right, I think that should. Okay, that is my bad. All right, so then we get 12 minus x squared, so it's just parabola downward facing, right? And it goes through negative 3, 3 and does stuff. Okay, cool. Same thing over here. And then this guy faces up, but starts down here, and we know where it's going to intersect. And so we get this nice picture. And so our area is exactly this green stuff here. And so what's on top? It's the 12 minus x squared, right? And so we're going from negative 3 to 3 of 12 minus x squared minus x squared minus 6. So this would be our area there for top minus bottom. On this one, again, I think graphing helps. You can also, right, set up the intersection points. So here this happens when 2 cosine is 2, or when cosine is 1. And on 0 to 2 pi, that will only happen at 0 and 2 pi. So at our endpoints. And that's going to happen at the y value 1. And then the actual cosine 1, right, it'll go down to minus 1. So, wow. Drawing's hard. Boom, goes down, hits -1 down here, comes back up, goes there. And then the other guy, right? So 2 minus cosine starts down at 1. Then when this is 0, it's going to just kind of do the inverse thing. And so it looks something like this, right? And so it's this area in between, this kind of cool shape. So as I think I heard Vinny say, right, our top one is the 2 minus cosine x. And then we would have minus cosine x. And of course, you could simplify this, right, to 2 minus 2 cosine x, but that's not really the point here since we're not computing it anyway. And then here we were actually told our bounds. We want to go from 0 to 2 pi. Okay. Let's do something else. All right, so C, y is cosine, and y equals -1 on 0 to pi. So this is another one that's pretty easy. You don't need to find the intersection points, right, if I give you this interval, but they do intersect at one place at pi, right, because cosine of pi is -1, but there is no other intersection point on this interval because cosine goes up to 0 there, so that's why I have to like tell you the x. That's not very straight. Okay, and so we're at 1, say pi over 2 pi. So cosine, again, starts up here, goes down here, -1, and then y equals -1 is just, boom, like this. And so the area we're talking about here, since I bounded it with x equals 0, looks like this. And so what's on top? Cosine. So this is 0 to pi of cosine -1. All right. Does this area come out to be negative? The areas will never come out to be negative, right? We always do top minus bottom. And so you always have something that's bigger subtracted by something that's smaller. So you always get positive, which makes sense, right? Because we're saying the word area. This isn't signed area, it's literally area. So it needs to be a positive number or else it just like doesn't really make sense. Yeah. Yeah, because even if they were both negative, right? Like if you have -2 minus -4, it's going to spit back a positive number. So like we ensure it by doing the top minus bottom or right minus left. Speaking of right minus left, let's do an example with y bounds. So we have, this is somewhat similar to the class prep one in a way. What about these two functions? So here, right, I'm not giving you an interval, so we need to figure out where these intersect. So we should set them equal. And this, unfortunately, is not super nice, right? Because we get 3y squared is 4, or y squared is 4/3, and then y is plus or minus 2 over root 3, which kind of sucks. And then you'd want to figure out, like, what is the x coordinate here? So you could just, like, plug it back in. So y squared was 4/3, and x is 2y squared, right? So x equals 2y squared equals 2 times 4/3, which is 8/3. So basically our two intersection points are 8/3 and then plus or minus 2 over root 3. 2 over root 3 is just like a little bit bigger than 1 because root 3 is like 1.7 something. So yeah, 2 is a little bit bigger than that. So 2 divided by it is just like a little bigger than 1. I think it's like 1.15 or something like that. Maybe. Okay. I think this one though, like once we find these intersection points, I mean the graphs actually are not that bad. So if we do 2y squared in red, the usual, I guess. So it starts at 0, 0, right? And then it's opening to the right, and it's just kind of a little bit longer and narrower because of the ×2. So here, I think, y isn't going up that fast, but the x is because of the ×2. So let's go ahead and do 2, 4, 6, 8. That should be good enough. So with 2y squared, when y is 1 or -1, we get 2. When y is 2 or -2, we are going to get 8. And so that's this guy. Okay. And then the other one starts at 4, and then it's opening the other way, right? So at y equals 1, you get 3. So we have something like here, and same with -1, and then at 2, and -2, it's going to cross. And so we have something that looks like this, and this, and so our intersection points are like here-ish, right? So just a little bit bigger than 1 or a little bit smaller than -1 on the y's, and a little bit bigger than 2. Again, this is like not to scale, so it's not perfect, but basically these are exactly these 2 points. And so this area in between, this is where I again want to show you that we care about doing y bounds just as much as we care about doing x bounds, because these are just like 2 nice curves that intersect. But if you try to view it using x, you have top minus bottom, different top minus different bottom. You have to split it, and you have to find 4 different equations, whereas this one is just one integral with 2 equations, right? This is just very quickly -2/√3 to 2/√3 of the one on the top is the one on the right, so 4 minus y squared in blue, minus 2y squared. Any questions on that one before we end stream? Okay. In that case, I'll go ahead and end stream, but I mean, I do have office hours for you guys from 2 to 3, so I will be around if you need me. Alrighty.